Hello and welcome to our channel. Today, we're going to talk about black holes and some of the most interesting and important things to know about them. But first, let's define what a black hole is. A black hole is a region of spacetime from which nothing, including light, can escape. It is created when a massive star collapses at the end of its life and becomes so dense that its gravity becomes overwhelming, pulling everything in. There are three main types of black holes: stellar, intermediate, and supermassive. Let's take a closer look at each of these types. Stellar black holes are the smallest type of black hole, ranging from about 5 to 30 times the mass of the Sun. They are created when a star dies and collapses, forming a black hole. These black holes are typically found in binary star systems, where they are orbiting a normal star. Intermediate black holes are larger and more massive than stellar black holes, with masses ranging from about 100 to 100,000 times the mass of the Sun. They are thought to be the remnants of the first generation of stars, which were much more massive than the stars we see today. Supermassive black holes are the largest and most massive type of black hole, with masses ranging from millions to billions of times the mass of the Sun. They are thought to be the engines at the heart of most galaxies, including our own Milky Way. Each type of black hole has its own unique characteristics and properties, and scientists are still working to understand more about them. For example, researchers are studying the effects of black holes on their surroundings, such as how they can distort spacetime and create gravitational waves. 2. Black hole event horizon. The event horizon is a boundary around a black hole beyond which no information can escape. It is the point of no return. Once something crosses the event horizon, it will inevitably fall into the black hole. The event horizon is named as such because it marks the boundary between the normal universe and the singularity, the point at the center of the black hole where the density becomes infinite. It is also known as the point of no return, because once something crosses the event horizon, it will be pulled into the black hole and cannot escape. The size of the event horizon depends on the mass of the black hole. For example, the event horizon of a stellar black hole, which has a mass of about 5 to 30 times the mass of the Sun, would be about the size of a small city. The event horizon of a supermassive black hole, which has a mass of millions to billions of times the mass of the Sun, would be much larger, possibly even the size of our solar system. The event horizon is not a physical boundary, but rather a mathematical concept that helps us to understand the behavior of objects near a black hole. It is an important part of our understanding of black holes and how they work. 3. Hawking radiation. Hawking radiation is the radiation that is emitted by black holes due to the quantum effects near the event horizon. It was first proposed by physicist Stephen Hawking in 1974, and it suggests that black holes are not completely black, as their name suggests, but rather they emit particles and radiation. Hawking radiation is a result of the uncertainty principle in quantum mechanics, which states that certain pairs of particles can spontaneously appear and disappear in a vacuum. These particles can be created near the event horizon of a black hole, where the intense gravitational forces can cause one of the particles to fall into the black hole while the other escapes. This results in the emission of radiation from the black hole, known as Hawking radiation. Hawking radiation has important implications for our understanding of black holes and the laws of physics. It suggests that black holes are not eternal and that they can eventually evaporate and disappear. This process, known as black hole evaporation, would release a tremendous amount of energy and particles into the surrounding universe. 4. The center of a black hole. The center of a black hole, also known as the singularity, is a point where the density of the black hole becomes infinite. It is thought to be the most extreme environment in the universe, with the strongest gravitational forces and the highest energy densities. The singularity is located at the center of the black hole, within the event horizon. It is a point of infinite density, where the laws of physics break down and our current understanding of the universe no longer applies. The singularity is surrounded by the event horizon, the boundary around the black hole beyond which no information can escape. The existence of singularities was first proposed by physicist Albert Einstein in his theory of general relativity, which describes the behavior of gravity and the structure of spacetime. However, it was later realized that singularities could also occur in other circumstances, such as the collapse of a massive star. The singularity is a mysterious and poorly understood place, and it is still the subject of much research and debate among scientists. Some theories suggest that the singularity might be a doorway to other dimensions or a place where the laws of physics are fundamentally different. However, it is currently impossible to directly observe the singularity due to the extreme gravitational forces and the lack of any known probes that could withstand the conditions. 5. Black holes and time. Black holes can distort time in their vicinity due to their strong gravitational forces. This phenomenon, known as gravitational time dilation, occurs because time appears to move slower in the vicinity of a black hole compared to farther away. Gravitational time dilation is a consequence of general relativity, the theory of gravity developed by Albert Einstein. According to general relativity, the gravitational field of a massive object like a black hole can bend and distort spacetime, and time itself can be affected by this distortion. The effect of gravitational time dilation on black holes is most pronounced near the event horizon, the boundary around the black hole beyond which no information can escape. Time appears to move slower the closer you get to the event horizon, and it appears to come to a complete stop at the singularity, the point at the center of the black hole where the density becomes infinite. The first image of a black hole was taken in 2019 by the Event Horizon Telescope, EHT, a network of telescopes located around the world. The image showed the supermassive black hole at the center of the galaxy M87, located 55 million light-years away. The image of the supermassive black hole in M87 was a major milestone in the study of black holes and helped to confirm many of the predictions made by scientists about the appearance and behavior of black holes. It also sparked renewed interest in the study of black holes and opened up new avenues of research. 6. Black holes and Big Bang. Some scientists believe that black holes may have played a role in the early universe, possibly even serving as the seeds for the formation of the first galaxies. The Big Bang theory is the prevailing theory of the origin and evolution of the universe. It suggests that the universe began as a singularity, a point of infinite density and temperature, and has been expanding and cooling since its inception. According to some theories, the singularity that gave rise to the universe may have contained black holes, which could have formed from the intense gravitational forces present at the time. These black holes could have then acted as seeds for the formation of the first galaxies, as the material falling into the black holes would have been compressed and heated, leading to the formation of stars and galaxies. There is still much that we do not know about the early universe and the role that black holes may have played in its evolution. Further research is needed to better understand the formation and evolution of black holes and their potential role in the early universe. Black holes and wormholes. A wormhole is a hypothetical passage through space and time that could potentially allow for faster-than-light travel. Some theories suggest that wormholes could be created by the intense gravitational forces of black holes. According to this theory, the intense gravitational forces of a black hole could create a tunnel-like structure through spacetime, known as a wormhole. However, the existence of wormholes is still purely theoretical and has not been confirmed by any experimental or observational evidence. Some scientists believe that wormholes may exist, while others are skeptical of their existence. 8. Black hole research in future. Black holes are still a topic of active research and there is much that scientists do not yet understand about them. Future research will likely focus on understanding more about the different types of black holes and how they form, as well as studying the extreme conditions at the center of a black hole and the effects of black holes on their surroundings. However, intermediate mass black holes are difficult to detect and study, and there is still much that we do not know about them. Another area of focus for future black hole research is the study of supermassive black holes and their role in the evolution of galaxies. Supermassive black holes are thought to be the engines at the heart of most galaxies, including our own Milky Way, and they play a key role in the evolution of galaxies. Scientists are working to understand more about the properties and behavior of supermassive black holes and how they interact with their surroundings. I hope you found this video on black holes informative and interesting. Thank you for watching.